So the first problem we're going to look at is known as the job scheduling problem or the interval scheduling problem. Okay. So the setting for this problem, the motivation is you have some resource, okay, that has to be shared amongst different jobs. Okay. So this can apply to many scenarios. Okay. So maybe you have for example, your resource could be maybe a fancy movie hall. Okay, maybe you have a fancy movie hall on campus where all air conditioned and you have very comfortable seats, and there are different groups, right, in college that want to screen movies there, right? And so there are a lot of requests from different groups of students who want to screen movies there. And now each movie will have, let's say you have, each group has constraints that we have a start time where they want their show to begin, let's say 9 o'clock, and it'll end whatever, let's say at 10:30. Okay, and there's another group that has to start the movie at 10 o'clock and it'll end at 12 in the noon. Okay, and so on and on, right? So the setting we are looking at here is each job has a some. So these jobs are these movies that we want to schedule on our single shared resource, right? The movie hall. Okay, and we have a whole set of such requests, such jobs that want to be scheduled on the um, that need to be scheduled, and the constraint is that no two jobs or no two intervals can overlap, right? So our maybe pictorially we have maybe this is the first interval, the first job, okay, that starts at 9 and maybe ends at 10:30, and then there's another job that starts at 10, okay, and ends at 12. Okay, so this is shown this way, right? It starts at 10, so it starts before the first job ends. Okay, so these two jobs are said to be in conflict. Okay, because there is a single resource, we cannot satisfy both these jobs. Okay, the resource can only satisfy one job at a time. It cannot multitask, so to say. You cannot screen two movies at the same time on a single screen, right? So it's clear that both these requests cannot be satisfied. So we'll have to pick one of them eventually, right? And we might have a whole set of requests, right? So these are all our jobs that need to be satisfied. Okay, also we'll call them as intervals. Okay, so each interval has some start time, some finish time. This is the start time, and it goes on for some time and finishes. Okay, so this is the setting that we have these set of jobs, set of intervals. Okay, this could apply, as I said, to other scenarios. You could think of your resource as being some fancy, uh, some fancy machine, right? Some in the lab, but the constraint on this machine is it can only execute one particular job at a time. Okay, so you have some high intensity, some high computational program, and the machine is configured such that it can only can work on one problem at a given time. And many students want to schedule their um, jobs on that machine. Okay, and for some reason, maybe you have these start times and finish times. You are constrained to, you have these constraints that you would like to start at this time and end at this time. Okay, so um, right. So maybe we'll write down our input to the problem. Right. So we have a set of intervals. Each of the intervals has a start time, each with a start and a finish time. Okay. And what we'd like to output is a scheduling. So what is that? We have to pick jobs, we have to pick intervals such that they do not conflict, right? So we maybe like to pick some intervals that, so let's say, for example, we pick maybe this first interval, then we pick this interval, we pick this interval and this interval. Okay, let's say we pick these 4 intervals and we'll say our these 4 requests will be satisfied. Okay, the intervals picked should not conflict, right? So if we see this interval here, it starts only after the first interval has finished. Okay, that was not the case for this one. This overlaps, this interval overlaps with this one. It conflicts, but this one and this one do not overlap. Okay, so they are non-overlapping. Okay, so all these 4 intervals that I have picked here, these do not overlap. Okay, they are non-overlapping. Okay, and as you see, there may be many different choices of non-overlapping intervals. Another possible choice is these 3 intervals. Okay, these 3 intervals are a set of non-overlapping intervals, or maybe these 3 intervals. These are also sets of non-overlapping intervals. So there are many possible sets of non-overlapping intervals. And so the output that we'd like to return is a subset, right? So clearly it's a subset of the set of intervals, right? We have to pick some intervals out of all the set of jobs, set of intervals. So a subset of, they have to be non-overlapping, right? Of non-overlapping intervals. Okay. So is any subset fine, or any non-overlapping subset fine? Well, we'll try and, in this problem, we'll try and maximize the number of requests that we satisfy. Okay, so we want to pick the highest number of jobs that can be scheduled without a conflict. Okay. So the output here is a subset of non-overlapping intervals of maximum size. Okay. I hope this is clear. Okay, so this is the problem that we are trying to solve. So what are possible ways that we could solve this problem? Okay, so maybe take some time and think of a way that you could solve this problem. Okay, the hint is this week is greedy algorithm, so there is some greedy strategy of solving this problem. Okay. So maybe, right, a first intuition, okay, some maybe one quote unquote obvious strategies. We want to pick the most number of intervals, right? We're not really concerned about the length of the intervals. We're not saying that we have to satisfy the intervals that are the longest or the shortest. It's just the number of intervals that we satisfy has to be the maximum possible. Okay, so if we want to do that, our intuition might say, let's try and satisfy all the small intervals, right? The intervals which are of small durations, because we might be able to fit many of them, right? We might be able to satisfy a large number of them if we pick the intervals that have that are the smallest, right? So that might suggest the following strategy. So let's call it greedy strategy 1. Okay, that's suggesting that there are more to come. But in this one, we pick the smallest interval. Okay, and we do it recursively, right? So what we'll do is we'll pick the smallest interval, and once we pick an interval, there may be some intervals that overlap with them, right? There'll be intervals that overlap with the picked intervals, and we have to definitely discard those, right? Because we have already picked one interval, so we discard those which overlap, and we continue. We pick the next smallest interval, right? And discard the ones that overlap with it, and continue, so on. Okay, so maybe if you're thinking about this algorithm, maybe pause your video. I really encourage you, pause your video and think whether this strategy might give you an optimal solution. So I hope you have reflected for some time. So the answer is no. Okay, this strategy may not work for some inputs. Okay, remember, we want a correct algorithm. We want an algorithm that will work for any possible set of intervals. Okay, so if you're saying it is incorrect, then it suffices to show one valid input instance for which the algorithm fails. Okay, so this strategy does not work. So again, if you have not figured this out, please pause your video and try to come up with a counterexample. Okay, try to come up with an example, a set of intervals for which this particular strategy of picking the smallest interval does not work. Okay. Okay, so I hope you have spent the time to try and think about this. So a simple counterexample would be this. So I have this one interval, I have the second interval, these two intervals, and I have this third small interval. Okay, so we clearly see in this case that the optimal solution is basically picking these two intervals, right? I can pick two non-overlapping intervals to satisfy, but the way the greedy algorithm would work is it would pick the interval which is the smallest, right? So it would just end up picking the smallest interval, and once we pick this interval, the algorithm has to discard the overlapping intervals. So it would end up discarding these two intervals and end up just picking just one, satisfying just one request instead of the two that can be satisfied. So here it is. This is a counter example. So this strategy, unfortunately, does not work. Okay. So what do we do? Okay. Sometimes when you come up with a counter example, that might give you more ideas for some other strategy. Okay. So in this case, what was happening is, if we look a little carefully, by picking this interval, we are throwing out two intervals, right? Because there are two overlapping intervals with this. But if we picked this interval, then we would just throw away just one. We would just have to throw away this interval. right? So this had a lesser number of overlapping intervals, just had one overlapping interval. So, right. So this might suggest another strategy. So the second strategy that we look at is what we are saying now is we'll try and pick intervals which have the least number of overlapping intervals, right? So in that case, we'll not throw out too many intervals, right? We'll just end up throwing out a few intervals. So pick the intervals which have the least number of or I'll just say least number of overlapping intervals. Okay, and we do this recursively as in the previous case, right? We pick an interval which has the least number of overlapping intervals, throw out the conflicting intervals, the overlapping intervals, and continue. Okay, so does this work, right? Does this work on this example? Well, it clearly works on this example, right? Because we would not end up picking this interval because it has two overlapping intervals, but we would either end up picking this one or this one in the first step. Okay, whichever one we picked, let's say we pick this one, it would end up only throwing out this one and it would end up picking the right answer. Okay, so it works for this example. Does it work for other examples? So maybe if you come back to this picture, does it work for this particular case? Okay. So maybe, so if you look at this interval has just one overlapping interval, right? And there is no interval here that has no conflicts, no overlapping interval. So this would be a good interval. It just has one overlapping interval. So we'll pick this particular interval. Okay, so if you pick this interval, now we will discard its conflicting overlapping intervals, which is this. Okay. So, and now we are left with the remaining intervals and we recurse, right? So let's see, maybe if you look at this interval here, it has how many overlapping intervals? It has 1 and 2. It has 2 overlapping intervals. Maybe let's write that down. It has 2 overlapping intervals. This interval here also has overlaps with 2 other intervals. This interval here overlaps with 1, 2, 3, 4 intervals. So that's a lot of overlap, right? So it overlaps with 4 intervals here. Okay, so similarly here, so maybe I'll write it down for all the others. This one has this particular interval here has 1, 2, 3 intervals with which it overlaps, and similarly for this one, which has 3, this particular one has 2. Sorry, that's 3 because it overlaps with 1, 2, 3. These 3 intervals. So you have 3 here, and this one overlaps with 2. This one overlaps with just 1. Okay. So now the algorithm would pick, after picking the first one, it would continue the same thing, right? It would pick the next interval that overlaps the least, which would be this particular one, right? So it picked this one and we would discard its overlapping interval. So we would discard this. Okay, and then we continue. So the next possible choices are these two intervals, which have only two overlapping intervals now. So I'll pick maybe this one, right? I'll pick this interval. So if I pick this interval, now I'll have to discard the ones which overlap. So yeah, so I discard this interval here and I discard this interval here, right? And now I'm left with just these three intervals. And now, well, these numbers will get updated because this now overlaps with these two, this overlaps with these two, and this one interval overlaps with these two. So all the remaining three intervals overlap with exactly two other intervals. So I can pick any one of them. Okay. So let's say I pick this particular interval, and that would lead me to discard its overlapping intervals. Okay, so I end up picking these four intervals. Okay, and in this particular case, I think four is indeed the optimal number of intervals that we can pick. Right, we cannot do better. Okay. So if you try out other choices also, it seems that this strategy, this greedy strategy 2, does work. Okay. So the idea of picking intervals which have the least number of overlapping intervals does seem to work. But well, unfortunately, it turns out that this strategy, this greedy strategy, also is incorrect. Okay, so that is to say that there are counterexamples, there are input instances. So there are set of intervals for which this strategy would not give the most optimal solution. Okay, so that I'm going to leave as an exercise. Okay, you can, unfortunately, well, the counter example for this takes some time. Okay, it's not very obvious. It will take some time to actually come up with a counter example. And I'd highly encourage you, really highly encourage you to take the time and figure this out. Okay. Try and come up with a counter example which will actually show that this strategy does not work. Okay, so I'm not going to give out the answer here. Okay.